Okay, so in this problem, you take advantage of the fact that this is a regular octagon. And since it's a regular octagon, all of these chords that make up the sides of the octagon are the same. And then by a theorem, that means all of the arcs are also the same. And so if all the arcs are 360 degrees, you divide by 8, and you find out that each one of these itty-bitty arcs are 45-degree arcs. And so now, knowing the theorems we know, we can find out a lot about this octagon. The first thing we're going to do is ECD. And so we look for ECD. Well, ECD is right here. And ECD is an inscribed angle. C is on the circle. And the arc endpoints of ECD are E and D, which has an arc of 45. So ECD is just half of 45, or 22.5. BCE, well, BCE would be this angle right here. And so it's going to be an inscribed angle, half of the arc that goes all the way around from B to E, which are 5 45-degree arcs. So you multiply 5 times 45, and then divide that by 2, because an inscribed angle is half of the arc. And so when you multiply that out, you get 112.5. So BC is 112.5 degrees. GFC is going to be this angle right here. Well, if you notice, GC turns out to be a diameter because it takes half of the octagon, and so GFC is just a right angle. 4 45s is 180, divided by 2 is 90, but it's just a right angle there. And so that's a very valuable thing. And then if you want to find FGH, well, you've got to know some things about this problem to be able to do it, but there are various ways to get there. Probably the easiest is to look at these two angles. If you look at those two angles, both of those angles intercept the arcs. So the angle E there intercepts this arc, right? Well, that arc is 90 degrees, so this is a 45-degree angle. And then angle EFC intercepts the same arc. So this is 45, which means this angle inside is just 90 degrees, because you've got two 45-degree angles. The other angle in the triangle has to be 90 degrees. So that angle is also 90 degrees. And so in a regular polygon, the starting point is the key, and that is dividing 360 by the number of sides, so you can find out what each of those individual arcs are.